Okay, this is now our trig review number 4. And for this review, we're going to be concentrating on the graphs of the functions. Graphs of the functions. Y is the sine of x. Y is the cosine of x, and y is the tangent of x. Most of the effort will be on the two waves. These are waves, but we'll also look at the tangent. And then in another video, we'll go and briefly look at the graphs of the reciprocal functions. Y is the secant of x, and y is the cosecant of x, and y is the cotangent of x. Okay. Now, as we start to approach this, we need to remember that whenever you're talking about a function, let's take the sine function to begin with. The variable x is called the argument. And for all trig functions, this argument must have, or the function must have, an angle as the independent variable. Okay, so when we write the function is the sine of x, we can think that x is some angle theta. So theta, again, any real number for the angle, negative infinity, positive infinity. On our axis, we can label this the x-axis and the y-axis if y is f of x. But we need to think of this not as an xy coordinate on the unit circle, not unit circle x, but angle theta, which we're going to be calling x. A little bit confusing since we did see x's and y's in the unit circle approach. This graph of the wave, however, is not going to be restricted to a unit circle, but rather x can go out to positive infinity or negative infinity. Okay, so negative infinity, positive infinity for the x. Interestingly enough, the wave itself, if we're looking at y is the sine of x, the wave itself is going to be limited between 1 and negative 1, which sort of makes sense if you think about the unit circle. Here's our little unit circle diagram. The sine being the y coordinate, it never got any larger than 1, never got any smaller than negative 1. Okay, enough about background. Let's go and sketch the wave. This wave has a repetitive, let's see if we can do that a little bit better, has a repetitive shape. This is said to be periodic. This particular shape will repeat infinitely, positive infinity and negative infinity. The maximum height of each wave, or each wave crest, if you will, occurs at 1. And the low spots, the troughs of the wave, if you will, are always down here at negative 1. And the location of these high and low spots are important. This occurs at pi over 2, pi, 3 pi over 2, and 2 pi. Notice that the wave length, right, or the cycle, or the period is the word that we use. The period is 2 pi. So every 2 pi, here's 2 pi, here's 4 pi. Every 2 pi, we get a complete wavelength or a complete cycle. So our cycle is going to be 2 pi. Let me erase some of this up here to get it out of the way. Okay, so there's a sketch, and of course these x coordinates would be noted. You should note the ones, you know, this is 3 pi over 2, this is 5 pi over 2. This is 6 pi over 2, which is the same as 3 pi. Right, this would be 7 pi over 2. This would be 8 pi over 2, which we already noted was 4 pi. And likewise in the negative direction, negative pi over 2, negative pi, high spot here at negative 3 pi over 2, and so forth. Okay, so there's a sketch of the sine wave. Some of the terminology that goes along with this, the period again, period is 2 pi. That's how long it takes before the wavelength is repeated, or the pattern is repeated, if you will. Okay, so that's one cycle. And if I were to drag that, you know, you should see that same shape every 2 pi. So if I were to bring it back over here, you'd see that set up. Okay, so that's our period, or our wavelength. The other words that apply in here are the amplitude. Amplitude is going to be 1. Graphically, the amplitude is the maximum distance the wave goes away from the midline. So this would be our midline. If you were a surfer, you would probably be more concerned about the wave height, which would be this. You know, this is the height from crest to trough, but that's not what we want. In trigonometry, we want the amplitude, which is half of the wave height. So from the midline of the wave to the top, that's 1 unit. Okay. The other things that apply to any function, whether it's, you know, trig functions or algebraic functions, we're interested in the domain and the range, and you can get those from the graph pretty easily. The domain would be the allowable x values. Domain, we said, was all reals. These angles can go anywhere from positive infinity to negative infinity. The range, on the other hand, the y values are stuck between -1 and 1. So we can just note that the y value is going to be greater than or equal to -1, less than or equal to 1. Notice that we have the closed interval here for the brackets. We actually do have points that have a y coordinate of 1 or -1. Okay, so there's a sketch of the sine wave. Let's do a quick, pull up a new screen and do a quick sketch of the cosine wave. F of x is the cosine of x. Again, x is an angle. So very similar to the sine, capped at 1 and -1. And the period is again going to be 2 pi. The cosine wave, however, starts up top and does this. Okay, and again, I'm trying to make these all the same. The wavelength is again 2 pi. So 2 pi for the wavelength, or the cycle wavelength. All those mean the same thing, 2 pi. So if we put some numbers down here on the axis, this would be 2 pi. The midway point would be pi. This point here would be pi over 2. This is 3 pi over 2. This is, again, 5 pi over 2. This would be 6 pi over 2, which we would normally write as 3 pi, of course. 3 pi. This would be 7 pi over 2. And then the second full cycle would be over here at 8 pi over 2, or 4 pi. And the wave will continue like this forever, both in the positive and the negative direction. We should label our axis. This is our x-axis, and this now is going to be our f of x-axis. If we decide to call this y, we can also call this the y-axis. Again, note domain is all reals, so the angle -infinity to infinity, and the range, just like with the sine, is going to be -1 to 1, closed. Now, for this particular sketch, let me make one subtle change just to sort of show you that these variables can be represented by anything. So I'm going to take And instead of calling it y is f of x, I'm going to call it y is the cosine of theta. So how does that change? This is still the y-axis, but now this over here would no longer be the x-axis. This would be the theta axis. And don't let that bother you. The labels would do anything here. The domain is still going to be negative infinity to infinity, but it would make more sense now to say theta is between negative infinity to infinity. Okay, so all real numbers, and the range is still going to be -1 to 1. Okay, amplitude is still going to be 1. Again, the wave height, if you will, top of the wave to the midline. Here's the midline. So this distance is 1. Okay, and again, the low spots would be down here at -1. The cycle or the wavelength, again, you can pick any particular section. So here's a section of the wave where it repeats, and you'll just note that as I move it along, it will repeat again every, whoops, don't quite have it matching up there, but every, let me make this one a little bit more accurate. There. So every 2 pi, this wave would repeat. So for example, in this blue section, I've got it running from -pi/2 all the way out to 3 pi/2, this distance right in here. So -pi/2 to 3 pi/2, and that's a distance of 2 pi. And so that's the wavelength. So I've taken that and I've put it again from 3 pi/2 out to 7 pi/2. That would be 2 pi. Now there's nothing magic about using that section of the wave. I could have used from crest to crest. So this green section is again 1 wavelength, and as I move it, we should again see a wavelength of 2 pi. Okay, so there's a little bit on the cosine wave. And lastly, the tangent for y is the tangent of x. We're going to note that this is not a wave, but rather it's a lot of broken pieces. And if I just tick off my axis here, this is going to be at pi/2, pi, 3 pi/2, -pi/2, -pi, and we'll go a little bit more, -3 pi/2, and one more over here. So at 2 pi. Okay, so here's x, here's y. The tangent, remember, we said was undefined at certain values. So the tangent was undefined at x is equal to pi/2. That was the top of the circle. Undefined at the bottom of the circle. X is pi/2. If you go, here's your unit circle. If you go, there's the top, there's the bottom. Bottom could be at 3 pi/2, so undefined there. These all turn into vertical asymptotes in the graph. Okay, now let's go ahead and sketch the tangent. Passes through the origin and goes vertically at these asymptotes. Passes through pi and goes vertically. Passes through 2 pi, starts to go vertically. Okay, so here's sort of a rough sketch of the tangent graph. And these are called branches. Branches, not really waves, branch of the tangent function. Some notes, the domain would be all reals as long as x does not equal these increments of 2 pi. X does not equal pi/2, nor any full pi past that. So x, for example, could not be 3 pi/2, or 5 pi/2, or -pi/2. Okay, so these are the numbers where the function would be undefined, corresponding to the top and bottom of the circle. So that's the domain, all reals except for those. And the range now is going to go from -infinity to infinity. So the range is going to be all reals. don't have a cycle or a wavelength here because this isn't a wave, but we do know that the graph will repeat every pi. So this now is going to be the period, and that is from negative pi over 2 to pi over 2, which is 1 pi. Okay, so from pi over 2 to 3 pi over 2, again, 1 pi. From 3 pi over 2, the next vertical asymptote would be at 5 pi over 2, and this is going to be 1 pi. So we'll just note that the period is equal to pi. We don't talk about the amplitude of the tangent, but you should certainly know the domain, the range, and the period. Those are the three things that you should know about the tangent function. Okay, so let's stop this here. Next video, we'll modify the waves a little bit and look at some changes. Okay, I know that was a long one. Stay with me.